What we have now is some questions that have been forwarded by the group. And I'd like to go ahead and open with a question that involves a very exciting, at least I think it is, new technology. Although it's not new globally, it's relatively new here. And the topic is called electrostatic precipitators. ESPs are devices that can be retrofitted onto a solid fuel burning device, onto a stack. And then I've been proven to be, under test conditions so far, and where they've been used somewhat extensively in Europe, places like Switzerland and other countries, very effective at reducing PM 2.5 and other particulate matter, PM 10, for example. The question is very specific, though, and the question is, electrostatic precipitators could be the technology that gets us to attainment. However, if we are only allowed to burn 20 days, that's how many days we were not in stage 1 or 2 last year, how will we be able to get enough information to let us know how these devices are actually working? And a second piece of that, are there incentives that can be given to those who are willing to try this, either from the state or the EPA? And I'm not sure which panelist would like to tackle the ESP question. I will... Okay, I'll hand it off to Nick.
To start with the data question, a very good question with, how are we expected to look at field data and determine, how, what the emission reductions of these devices are if there's not very many days that you can burn and utilize them. And the first thing is when we're going out to collect data, we can certainly collect data and still comply with the state's current rules. I think there's opportunities. You could go to the Fairbanks area to collect data, or you could move outside of the non-attainment area in order to do your data collection. And then that would help get the necessary proof that whether or not these things function and how well they function. And with the ESPs, there's currently there's nothing prohibiting folks from going out there and putting an ESP on a device right now. I think the real sticking point is whether or not they'll be granted a waiver. And when we're in a serious non-attainment area such as this, we have to fully vet a technology before it gets used in the plan as a waiver to a curtailment program. And then I can pass that on to Alice for additional.
No, I think that's a good point. And DEC heard very clearly from the community during the public comment period about the desire to be able to promote these innovative technologies, to learn more about them. I can't say at this point what the decisions are going to be made around ESPs in the final plan. We certainly heard that. We certainly don't want to discourage the exploration of the technology in this community or the use of innovative devices. As Nick said, there's nothing that prevents anyone from putting an ESP on a unit here in the borough, and we're certainly considering all the comments we received related to waivers and other aspects associated with ESPs and innovative technologies. So I apologize I can't give you a decision on where that's all going to come out at the end, but it's certainly something we're aware of. We want to continue to encourage the data collection that is going on and the efforts that are being made in the community to look at this technology to see how it works here. And I would say that, data is helpful to us, especially in a regulatory, when we're looking at it for more of a regulatory framework. That's always helpful. Krishna might have a little bit to add on that too.
We're excited when new technology comes to the fore. EPA has had experience looking at experimental technologies and approving them or not approving them. And we make sure that the device, because it's used for public health and it has to withstand the highest level of standards of scrutiny, that it's done in a very rigorous way. And if it comes to the regime, if it's applicable, so people do approach us to say, I have this unproven technology, but it cures all water quality issues. And so we we accept that, but we show, okay, we want to see the test results, the protocols are solid, and whatever regime it takes for that device to prove itself consistently across all conditions, using all standards, all variations of data collection, and using statistics. So it has to withstand not only performance of the device itself, the maintenance it takes to perform at the level that it is intended to, and so the framework it needs to make it to be successful. An example I can provide is, so electrostatic precipitator is something we're very familiar with in industrial applications, large-scale industrial applications, and it works in a certain way. It works differently for each industrial application, and if somebody comes and tells us that, well, this is going to work at 99.99% for the duration of this machinery for the next 100 years, we have a hard time with that. It doesn't. You just cannot stick something somewhere and hope that it performs its peak efficiency across its lifetime. It takes a maintenance regime. It takes an operation and maintenance plan to do that. It probably takes investment and cost. So the truly understanding of the steps it takes for the machinery to perform and the cost you include in that is critically important. So we'll be making these comments to the protocol that's going to be used here, and make sure that the community understands that there's a high hurdle. It's not going to be something because it concerns public health. If we say that this is going to offer X percentage reduction, and then we have to stand behind it and say to everybody that this is what it's going to do, and the ultimate when we come to look at it, if it doesn't meet the standard, that's going to be a liability that we're going to answer to. So, and by we, I mean the citizens, to the citizens of the United States, and including the citizens of Alaska, including the citizens of Fairbanks. So there's challenges to that. There's no doubt when you have embarked on a new, testing out a new technology, and this is from 50 years of experience. So it is very challenging to prove in the community. You're going to work through some of those challenges as a community, come together, and figure out those challenges. But those are some of the frameworks from our experience that I can tell you what it takes to prove a technology to be used in the community. But we're very excited that it has emerged, and look forward to hearing more from the testing. Oh, okay.
Right. The second part of the question involved, are any incentives going to be considered by the DEC or whoever, I guess, for using these devices?
It's not my call, but I can definitely go and research that. What kind of grants are available for technology testing or piloting? That's something that I have to go back and look at. I don't have an answer right now, but it's not a no.
And I didn't say no either. I said that the DEC is actively considering all the comments we received. I just can't give you an answer today on what that answer is or what that looks like. So if you're looking for a definitive answer today, you're not going to get a definitive answer from DEC.
I think the question is just misunderstood.
All right.
What I'm asking is that if individuals are willing to put out the money or to go, and put this on, with the DEC or EPA, because right now there's no incentive to do it. You're just out the money and you're trying to make air cleaner. And just wondering what the incentives could just for the individual who decides to go this extra length to have clean air, could that possibly be looked at? So I'm not looking for grants and other money, just to that individual, is there something that could possibly be looked at? Then
And I think that that is something that we are looking at in the context of the plan.